So, good day, sir. Good day, everyone. I am Johanna Marisa Beliano from BSME 2-B, and I'm going to report volumetric efficiency of a gas compressor. So, under gas compressor analysis na topic, this is the second part or second report. So, as a review with the introduction of the gas compressor, the gas compressor increase the pressure of gas by reducing its volume. And also, as gases are compressible man, so the compressor also reduces the volume of gas. So now let us know what is volumetric efficiency. So volumetric efficiency that will be seen in the next slide is the measure of the deviation from volume handling capacity of compressor. Mathematically, the volumetric efficiency is given by the ratio of actual volume of gas drawn in and swept volume. So ideally, volumetric efficiency, so the volume of air should be equal to the swept volume, pero dili na siya in actual cases. The volumetric efficiency also lies between 60 to 90%, and it represents the efficiency of a compressor cylinder to compress gas. So, di ba, we aims for higher capacity man sa compressor. So, the volumetric efficiency should be higher sad para ang ihang capacity pod kay higher pod. So, in order to have a higher capacity or higher volumetric efficiency, dapat kay ang clearance nimo na volume is small, and then ang rotation nimo kay dili siya high speed. Bali, it should not have a high-speed rotation. So, and now I have here the conventional formula for the volumetric efficiency. So, for the volumetric efficiency, the conventional volumetric efficiency or the generally used or believed na formula for volumetric efficiency, it is the volume of gas drawn in over displacement volume. So it can also be written as N sub V equals V sub 1 prime or volume 1 prime over volume D or the displacement volume. So ang volume of gas drawn in or the V sub 1 prime is obtained by subtracting the volume 1 and volume 4. So volume 1 minus volume 4 will be the volume of gas drawn in over the displacement volume. So the displacement volume is the volume swept by the face of the piston in one stroke. So the clearance ratio or percent clearance C can also be obtained by dividing volume 3 and the displacement volume. And also, you can have the volumetric efficiency by 1 plus C minus C. So C refers to the clearance ratio or percent clearance multiplied to the pressure ratio, which is pressure 2 over pressure 1 raised to the power of 1 minus N. So if the compression process is isentropic, let N be K. So let N is equals to K. And then you can have or you can get the displacement volume VD through pi over 4 times D squared times L times N, where this D refers to the diameter of the piston, L refers to the length of the stroke, N refers to the number of cycle completed per minute. So, ang number of cycle completed per minute can be obtained by N times 1 or the number of cylinders for single-acting compressors. And for double-acting compressors, it would be N times 2 times the number of cylinders. So ang N, it refers to the compressor speed or revolution per minute. So kanang mga nag-RPM dira na mga given, kaya mo na siya ang compressor speed. And that is this small letter N. And then before we go to solving a volumetric efficiency, na kay dapat i-consider pa the single acting compressor and the double acting compressor. So under compressor types, there are two, di ba, na types. So the positive displacement and the dynamic. So in positive displacement, we have reciprocating and rotary. And in reciprocating, we have single acting and double acting. So we will be going to focus on the single acting and double acting reciprocating or reciprocating na compressor type. So first, let us talk about the single acting compressors. So a single acting compressor makes one complete cycle in one revolution. So ang single acting compressor is a famous type of positive displacement compressor. So it uses compressed air to push the piston in one direction and the spring force to send the piston back to its primary position. And also, the cylinder of this reciprocating air compressor uses only one piston for supplying and discharging pressurized gas. So the piston of the single acting na compressor works only in one direction. So ang piston niya works only in one direction. That is why it makes only one complete cycle in one revolution. So with the single acting compressor, the whole compression process is carried out in only one step. So ang kiniang single acting compressor, it is consist of intake valve and exhaust valve, the cylinder, the valves, and the piston. So at the end of the delivery stroke, aning a single acting compressor, a certain amount of high pressure air remains in the clearance area. And since the single acting air compressor has only one valve at the top of the cylinder, so that means that there is only one compression cycle for each revolution of crankshaft. So, di ba this is the cylinder. Above the cylinder nara na siya usa ka valve. So tungod kinam siya usa ka valve, that also means that kanaang there is only one compression cycle for each revolution of crankshaft. So kada usa ka revolution sa crankshaft kay usa ra ka compression cycle ang ma-complete sa single acting compressor. So I have here a PV diagram sa single acting compressor. So we have here the A, the B, the C, and the D. From D to A, so sa D to A na kanaang operation, we have the suction stroke. So sa suction stroke, the air is sucked into the compressor. So in this area, so the air is sucked into the compressor cylinder at constant pressure P, and the volume of the air increases during the process. So there volume sa air ano niya increases during sa dira na process. The next process is from A to B, which is the compression stroke. So from D to A, we have A to B. So in the we can see in the PV diagram, di ba? So mo ni siya ang compression curve. So nadra ang compression stroke. So after completing a suction stroke, after completing a suction stroke, the air compression starts. So during this process, the air pressure increases. So the air pressure increases and the volume decreases. Now at this point B, the pressure P is marginally more than delivery pressure na siya. So this is the delivery pressure. So at this point, ang pressure kay marginally more than the delivery pressure. And then the next process is from B to C. So from B to C, we have the delivery stroke. So at point B, the compression stroke completes naman. So the compression strokes completes diri na cycle or diri sa B na cycle. And then the delivery stroke starts. So during the process, the air pressure remains constant while the volume increases. So at this stage, the outlet valve opens and discharges the compressed air. Then the next process is the repeating process, or here from C to D. After completing the delivery stroke, the piston comes again for the suction stroke, again sucks air, and at this stage, the cylinder pressure will be P. So ang cylinder pressure niya will be P. And this process repeats according to our other requirements. So, and also the work is done during this process. So ano na ma-end? So from suction stroke, mag-compression stroke siya, and then delivery stroke, and then the repeating process. And then the next type of reciprocating compressor is the double-acting compressor. So the double-acting compressor makes two complete cycle in one revolution. So in the single-acting compressor, kay only one side of the piston naman to ang mo work. So sa kanang double-acting compressor, it is a little bit different than the single-acting compressor. So the piston of the double-acting compressor works on both sides. So if sa single acting kay ang one side niya ang work sa piston, here sa piston kay the both sides works. So when the piston moves backwards, then it sucks air. When it moves forward, then it compresses air. So ang piston, if it moves backward, it sucks air. It moves forward, it compresses air. So a single-acting compressor, the additional info, a single-acting compressor works efficiency is mga 22 to 24 kilowatts. And then ang double-acting compressor is from 15 to 16 kilowatts. So with that, compressors produce cheap electricity compared to single-acting compressor. So since 15 to 16 kilowatt man ang sa double-acting, and then the single-acting kay 22 to 24 kilowatt yung work efficiency. So mas nag-produce siya og cheaper na electricity compared sa single-acting for the same amount of compressed air. So ang double-acting compressor, so nani siya yung mga components. We have the cylinder, the piston rings, the piston rod, wrist pin, crosshead guard, the crosshead, the crankshaft, the crank pin, and the connecting rod rather. So the cylinder, it is included and it's very essential in the double-acting compressor. So if kining cylinder kay ma-damage ni siya, the compressor allows you to easily replace it with a new line or with a new liner without replacing the entire compressor. So maguba na yung cylinder, whether na mo siya ilisag liner without changing the whole compressor. Kaya na may uban na kung maguba na part kay isa na dyan imutanan, diba, na may mga nana. So next we have the piston. So ang piston, it moves up and down in the cylinder. So this is the cylinder, so the piston will move up and down. And then the movement, ana siya kay known as the reciprocating movement. So the piston sucks and compresses air during its motion. Also, we have the connecting rod. You have here the connecting rod. So it makes link between the crankshaft and the piston. So ang connecting rod, it makes link or nagatag siya og link para makonect ang crankshaft to the piston. And then one side connecting to the rod, and then the other side connects to the crankshaft via connecting rod cap. So kini siya by connecting ani siya mo to na connect siya sa crankshaft, and also it connects to the piston rod. So we have also the piston ring. The piston ring circulates around the piston. So mo ni siya ang piston ring. So mo to siya. Those are some of the relevant na mga kanaang excuse me. Those are some of the relevant na components sa double-acting compressors. Though, importante mo siya tanan, so, katulang sa ato i-focus. So since nakaibaw naman ta sa single acting and what is double acting compressor, we will now have a sample problem.